All right, starting on number 14, this page deals with piecewise functions. So if those of you that have been still struggling with these, let's kind of walk through these and just talk about how to construct them, both the graph from the function and the function from the graph. So looking at this first one, draw the graph of the piecewise function, then evaluate the function for the given value. So we're looking at h of x here, and it looks like it's going to have 3 pieces when we're done. And remember, we talked about these domain restrictions here. That's the piece of each line, right, that we're going to keep. So again, you guys should know how to graph this mx plus b. We said, right, you have your slope here, you have your starting point, you'd be at -4, and then you would go up 1 over 2, up 1 over 2, and you could construct this line. However, we don't want the whole line, we only want the part that is less than -2. So you can either draw this whole line, and then you can stop it right here at -2, and, oh, that's a terrible line, but draw it out with the same slope. Or we can plug the value in and use those barriers. So either way you'd like to do it. Again, if I was drawing in the barriers, and remember this is not necessarily part of your final graph, but I just want you to see, if we were to think about a barrier being here at -2 to start with, we know that the first piece has to be only on this side of that barrier. Then the next piece, it looks like, lies between -2 and +3, so at +3 it's almost like we've got our other barrier here. And we know that the next piece is going to lie between these two barriers. And then this last piece is x is greater than or equal to 3, right? So it's on that side of 3. So those are our 3 pieces, and then we just need to plug them in. Now, we talked about if you just plug in the domain values, it actually gives you where the function would be on those barriers. So, for example, if we take this -2 on the first one, we come over here and plug it into our function. That would be 1/2 times -2 minus 4. 1/2 times -2 is -1 minus 4. So in this case, we're looking at -5. So when x is -2, right, on that barrier, the y value is going to be at -5. So at -2, we're going down to -5, and I'm going to put an open circle. Remember, it's an open circle because this is less than, but not or equal to. And then just use that slope. So our slope here was 1/2. So I'm going to go down 1 over 2, right? We want to make sure that we're headed away from the barrier. If you find yourself heading this direction into that barrier, remember we can't cross that. So you need to go the other direction with your slope. All right, then we do the same thing for the next one. So notice now I've got 2 barriers, right? One on the left, one on the right for this next piece. So I'm going to put the -2 in first. I'm going to write it down here. If I have -2 times -2 plus 2, negative times a negative, that's a +4 plus 2. So that's going to give me 6. So at -2 on that barrier, I'm going to be clear up at 6. And notice this one is less than or equal to, so we are going to close in that circle. We can do the same thing with the right side of this one, domain restriction. So we put a 3 in for x. So that would be -2 times 3 plus 2. That would give us -6 plus 2. And it looks like we're going to be at -4. So when x is 3, over here on the barrier, we're down at -4. And again, if we look at that one, it looks like it does not include. So we're going to leave that open. And then we just connect those. And one thing that I really like to do is once I've connected those and I've actually drawn my line in, I just check to see if the slope and the y-intercept match, because this one does cross the y-axis. So notice here your y-intercept or your b value was at 2, and that looks good. It's right there crossing at 2. My slope should be a -2, so that looks great as well. It's going down 2 over 1, down 2 over 1, down 2 over 1. So just check that your slope is matching what you want it to. And then lastly, again, I'm just going to put this 3 into my last function. So if I have 3 subtract 7, that's -4. So on that barrier at 3, oh, this one's going to be at -4 as well. Notice those are the same point there. So that's actually going to fill that circle in because it includes that one. And then it looks like we have a slope of 1. So 1 over 1. So I'm going to go up 1 over 1, up 1 over 1. And this line is going to head off this direction. Again, when we're done graphing, we just make sure that nothing crossed the barriers. So notice this passes the vertical line test. It touches the function only once. Nothing's breaking into someone else's barrier. So I don't need those little barriers anymore. And we would have the function there. Now, as you're evaluating over here, remember h of 4, we're saying, well, when x is 4, what is the function value? Two ways you can do this. One, you can use the graph if you graphed it correctly. The other is you can come over here and you can look at, I'm going to erase some of this thing. You can look at your function. So we say, where does 4 as the x value fit in, right? 4 is not less than negative 2. 4 does not lie between negative 2 and 3. Oh, it's making those ovals. So this is the one that 4 is actually greater than or equal to 3. So we're going to use this piece to evaluate, and we're going to put 4 in for x. So 4 minus 7, which would be negative 3. So h of 4 is negative 3. And again, you can see that on the graph, because when x is 4, the function's right there at negative 3. Okay, time for our very first mathy joke here. So you're going to write this very end of your review. What shape is usually waiting for you inside a Starbucks? A line. Of course it's a line. Always lines inside of Starbucks. Maybe not these days. I don't know. Haven't been for a while. Okay, that's your first one. So you're going to write down that punchline there. All right, number 15, write a piecewise function g of x for the graph function graphed below. Okay. A lot of words there. Be sure to use correct notation. Notice down here looking at it, the first thing we always look for is how many pieces, right? So we've got a line coming up here. There's one piece. We've got one headed this direction. There's one piece, and then this one has a pretty steep slope, so that's on the right side. It looks like it ends right there, and it continues forever in the left direction. So I know that I'm going to create my function over here. And remember, you need g of x is equal to, some of us forgot the equal sign on our mid-quarter exam, make sure you have that. Then we start to construct our pieces. So just like we talked about in the last one, it looks like the pieces split right here, right? There's one at 0, and this guy's always left of 0. So we know that this first piece, when we write its equation, this one is going to be where x is less than, and we could include that point. Now it overlaps, so it doesn't matter which one I include it with as long as I just include it with 1. X is less than or equal to 0, right? That's our first barrier. And we know that the next piece starts at 0 and then is between 0. So here's our barrier, right? The next piece ends, it looks like, at a positive 3. So 1, 2, 3. That would be like our next barrier there. So this guy goes all the way to 3. Now again, you can include the 3 if you want, and then just don't include it on the next one. The next one looks like it goes between 3 and then it actually goes over to 5. So we're looking at this barrier right here where this piece is. So 3 to 5, we're going to sandwich x between there. And I'm going to include 5 because it looks like that's the closed circle there. So I'm just checking those domain restrictions. 1 is always on this side of 0, right? This one's between 0 and 3, 3 to 5. None of those overlap, so we are good there. Then we write the equations of the line. So remember, to write the equation of the line, we need mx plus b. We need slope here, and we need our y-intercept. So this first one's pretty simple. It looks like we have a point here and a point here. So we're going to count, right? It goes up 2, and then it looks like it goes to the right 3. So in this case, rise over run would look like 2/3 x. There's our slope, and our y-intercept is there at 2, so we put plus 2. So that first piece is pretty simple to construct that equation. The next piece, we're going to do very similar things. So I'm going to start here, and I'm going to move to the other end of our piece. So it looks like this one goes down to 3, so we're going to go down 3, and then this one's going to go to the right 2. So this one looks like, oh, it's not going to the right 2. I apologize. That's going over 1, 2, 3. So this one looks like it has a slope of -1, right? -3 over 3. So this slope would be like -1x, or you could just write x. And then notice its y-intercept also met there at 2, so this one's also plus 2. This last one's a little bit trickier, so let's work through it. Again, if I'm going to look at slope, that's not too bad. It looks like it goes up 1, 2, 3, 4, 5 to get all the way up there. And then it looks like it's going over 2. So it looks like we've got 5 halves, x. And then we need to know where it's going to cross. Now notice this guy, if I were to continue him down here, he's going to come clear down here and then he's going to cross the y-axis somewhere down here. So I know it's a negative number. I know it's going to be a subtract here, but I do need to figure out what that number would be. Now most of you, it seemed like at the beginning of the year, were more familiar with point-slope form. So if I want to find the y-intercept, I can use a point and slope, right? And that was the y minus y1, and you use your slope and some point xy. So let's say we know our slope is 5/2, right? That's our slope. And one of the points that this piece crosses in is either this 3, -1 at the bottom or up here at 5,4. So maybe I'll use the 5,4. Okay, and then I'm just going to plug it in. So I'm going to do y minus my y value. The y value I chose there was 4. And my slope is 5/2, and then I go x minus my x value, which in my case was 5. And then we just move that around so that we can figure out this y-intercept. So we've got y minus 4 is equal to, we distribute the 5/2. We get 5/2 x minus 25/2, it looks like. And then we just move the 4, right? So we're going to add 4 to both sides. Now if you add 4 here, if I want to add that as a fraction, the denominator here is 2. So I'm going to multiply that by 2 to create a common denominator. So 4 really becomes 8/2, right? 8 divided by 2 is 4, so I'm going to add that. So in this case, it's like 5/2 x minus, you have -25 plus 8 is 17/2. So here's my y intercept, -17/2. So it's really going to cross clear down there at -8.5. And you can write it as -8.5 if you'd like to. That's really the hardest part of those, is creating those equations if we can't see the y-intercept. Other than that, again, those barriers can be seen, and we just need to make sure that we're comfortable with constructing our mx plus b. The second part says evaluate for the following. So again, we can use our function that we created or the graph. G of 2, if you guys look at 2 over here, right, when x is 2, where is our function? Well, it's crossing at 0. So using my function, I can actually tell that this one is 0. Again, if you wanted to use the function you built, the equation, remember we would look to figure out where 2 fits. So 2 is not less than or equal to 0. It is between 0 and 3, so we would use this piece right here. So if I took -1 and I multiplied it by the 2 I'm putting in plus 2, that would give me -2 plus 2, which is 0. So either way there. The next one's a little harder to tell from the graph, so this one I would use the function. So at -2, it's hard to tell kind of where it's at. Now remember, it is going up by 2/3 every time, so I actually know that's going to cross at 2/3 there, but we could use the function to identify that. Again, -2 is less than or equal to 0, so we're using this top piece right here. So we're going to say 2/3 times -2 plus 2. We multiply -2/3 times -2, that's -4/3. And again, if I want to put 2 into a fraction, right, it's now 2/1. I want a common denominator, so I multiply it all by 3, so that's the same thing as 6/3. And -4 plus 6 is a positive 2/3. So we're looking at, again, 2/3 as that function's answer there. Okay. All right, draw a diagram of the number system below and include at least one member of each set. So remember, the only one we really don't include is the real number. You can put a number in there, though. So let's just kind of construct this really quick. The first one is the natural numbers, so just make sure we're comfortable. That's like 1, 2, 3, anything bigger, right? That's a 2. Whoops. The next one is the whole numbers. Whole numbers include 0 and then continue up 1, 2, 3. The next one after that was we put in some negatives. They were called integers. Their symbol was a z. So any negative number you can throw in there. That's a -5. Wow, my numbers are hard to read. Then the next one we said was the rational numbers. So if we throw in some fractions, that's a q, and we call those rational. Outside of the rational, right, we have what we call irrational numbers. Their symbol was a p. So if they're not rational, They could be irrational. Those would be like pi or the square root of 3 or some number that does not have a repeating decimal or end nicely. These numbers can all be found on the real number line, right? So these are our real numbers. And outside of that, we talked about this year we're going to learn, and we put a cloud to help us remember, about imaginary numbers. So if they're not found on the real number line, we could have imaginary numbers where negatives start to show up in square roots, or we use the symbol, little cursive I, to write our imaginary numbers. And then lastly, around the whole outside, we talked about we have what we call complex numbers. So complex numbers, they have real parts and imaginary parts, since they go around the whole outside. So you just choose any real number like -3, plus an imaginary number like 10i. Okay, there's our number system. Okay, for our next joke, now I tell you math jokes are quite cleverly ridiculous. Okay, the next one is, how do you make 7 an even number? The answer, just take away the s. Then you have even. Huh, love it. Okay, number 17. The set 1, 2, and 3 and ... would represent the set of whole numbers. Is this true or false? Looking at that number system we just drew, right? We know that 1, 2, and 3, they are in the whole numbers, but they also include the value 0. So this would actually represent the natural numbers. If I want the whole numbers, I need to include 0, 1, 2, 3, all the way up, right? And these just mean a set of numbers. So we are going to say that this is false. All right, let's start in a couple on the next page, and then we will end this video and start to the last one. So these ones going back to performing operations. So I'm just going to work through these quickly. Remember, we just looked to see if it's addition, multiplication, or subtraction. This one looks like it's addition, so we're just combining like terms. No need to start to try and distribute. It looks like I have a -7r cubed, and I have an r cubed. That would give me -6r cubed. I have an r squared and a 4r squared, which would be 5r squared. And then you've got lastly your 4r and your -5r, which would be just -r. So in this case, if we look at all those options, it looks like A is going to be our correct answer. On 19, this one's multiplication, right? There's no addition or subtraction between there, so we do need to distribute. So we start to FOIL. 7n times 2n is 14n squared. 7n times -8 is -56n. -1 times 2n, -2n, and -1 times 8, +8. We combine those middle terms, and we get -58n. So it looks like, again, we're looking at A. Number 20, not multiple choice, but again, just a foiling. So 4m times m is 4m squared. 4m times 1, +4m. -2 times m, -2m, and -2 times 1, -2. We end up with 4m squared. We combine the 4m and the -2m. We get +2m minus 2. Okay. 21, we look at this one and we remember that this means there are 2 of these that are identical, right? It doesn't mean we can try and distribute that squared inside there, or we lose the middle term. So we put these side by side, then we start to FOIL. We get 25. 5 times 8v is 40v. We get another 40v on the inside there, and then 8v times 8v is the 64v squared. Now notice in the instructions it asks us to write it in standard form, so I'm going to reorder this as I combine like terms and put the 64v squared at the front. I'm going to put 80v and then plus 25. Okay. All right, we're going to stop there. We'll start the next one and finish out with our factoring.